Databases that have vector search capabilities enable developers to build powerful applications that can search data in their database for semantic meaning rather than exact matches of the text. Google Cloud Spanner database has had vector search capabilities for a while now, leveraging exact k nearest neighbor algorithms, known as ScaNN, for workloads that are highly partitionable. Now, Spanner is introducing approximate nearest neighbor search, or ANN, to enhance similarity search on large datasets. Let me show you what that means and how it works. Exact k nearest neighbor search, KNN, in Spanner is great for datasets that are highly partitionable. As an example, I have the Finvest app that allows me to search across a database of mutual funds using different criteria to find the right mutual funds for me to invest in. I'm looking for funds that invest in equity in emerging markets in Asia, so I'll type that in as my natural language search. And I'm certain that I only want funds managed by Luisa, because I've heard good reports about them. This query can leverage a standard index created on the Investment Managers column to perform the KNN search for all funds managed by Luisa. If I didn't limit the results of my mutual fund search, or I didn't have an existing index that could be used to filter my results, the exact KNN search would perform a full table scan over all my mutual funds. I would be guaranteed the most applicable results to my question, but it could be very slow getting those results if the size of my data set grows to millions or even billions of records. This is where ANN comes into play. With approximate nearest neighbor and Spanner, using a new vector index type and the new approximate distance functions, my query will be much faster at the cost of a small amount of recall loss. To leverage the ANN search, I need to adjust my schema and my query. First, I'll add the vector index on my embeddings generated from mutual fund investment strategy descriptions, which are stored in Spanner. Now, my query needs to be adjusted to make use of the new vector index. I use the approx Euclidean distance function to calculate the distance between the embeddings from my natural language prompt and those stored in Spanner. I've decided not to search for fund managers to limit the size of my results like I would need to with exact KNN, and my query is still very responsive. It was amazingly simple to improve the response time and functionality of my app. All I had to do was add an index and tweak the query, and I can now search across all the mutual funds in my Spanner database. In this example, I used the approximate Euclidean distance function, but there are approximate functions for each distance function that Spanner supports. Now, let's take a look at how the vector index works. The new vector index in Spanner leverages Google's scalable nearest neighbor, SCAN, algorithm to organize embeddings into clusters. Each cluster is represented by its centroid, which allows us to scan only the most relevant partitions for our search. Based on the SCAN clustering algorithm that I just described, the vector index is implemented by a specialized tree-like data structure, with the root containing the centroids for all clusters, and each leaf partition maps to a single centroid in the root. During query time, only a small number of centroids closest to the query embedding are chosen, and embeddings in the corresponding leaf partitions are scored. Google's ScaN algorithm is a state-of-the-art nearest neighbor algorithm that enables fast lookups over a large dataset with high recall. Leveraging this technology allows Spanner customers to get the benefits of using SCAN simply by adding a new Spanner index. As a horizontally scaling operational database, Spanner has always been able to maintain great performance as datasets scale from very small to very large. Applications like the mutual fund example shown in this video can now leverage the new ANN features to take advantage of Spanner's great performance at any scale. But there are many other use cases beyond financial apps that can make use of Spanner's ANN features. They can be combined with large language models, LLMs, to create useful Gen AI applications. Let us know in the comments below how you can make use of Spanner's new vector search capabilities in your application. And then, go try it out for yourself by following the code lab linked in the description below.